लिंक आली सर, मी
Oh,
पाठवते लिंक.
yes, पाठव. So, very good afternoon to all my dear students, and welcome for the third session of pre-placement activities, and specifically which is on this day happening on C programming language. And we had a discussion. Previous two sessions we have covered a lot many points, and the last point I believe what we discussed was related with the array and the function and recursive function. So let us visit to one of the very appealing feature of C programming language, which is called as a pointer. And the pointer allows us and provides us with the ability to directly manipulate the contents of the memory. And then that is the reason, okay, pointer is regarded as one of the very powerful feature. And especially when we are trying to propose system level programming, we are trying to play with some okay, device drivers or terminate and stay resident kind of an programs. The pointer becomes a great utility. So what is a pointer? A pointer basically is kind of a variable, but the only difference is that, okay, pointer is meant for holding an address of another variable. And in our trailing part and concluding part of the last session, I was telling you that every variable we declare in our program, in fact, okay, consumes an appropriate amount of memory. And how much of a memory and how many memory locations basically, okay, the variable will consume, how many bytes it will consume, depends on the data type of that variable. So for example, there is a very set standard that the size of the float in C programming language is 4 bytes. And as far as an integer is concerned, so on some platform like Linux and on some IDs, it consumes 4 bytes, or sometimes it consumes 2 bytes. It all depends upon what is the word size of the platform you are using. But let us assume that, okay, integer consumes 2 bytes. So if we have this kind of a declaration, which is there in front of you, so I will say that the integer x variable will consume 2 bytes, and okay, the y variable will consume 4 bytes. Somewhere in the memory, the chunk of 4 bytes will get allocated here to y, and chunk of 2 bytes will get allocated to x. So हमने देखा था कि last time and is an address of kind of an operator, and asterisk can be regarded as a value at address kind of an operator. So that's the reason address of x is 1054 and address of y happens to be 1050. And similarly, if we say that asterisk ka matlab value sitting at this address, so value sitting at this address 1054 is 20, and value sitting at an address 1050 is 3.5. So how exactly we should declare the pointer? It's very simple. You need to have a variable declaration going something like this. You need to specify the data type and followed by the pointer name or variable name preceded by asterisk, because asterisk is an identity of a pointer. And then we can make use of these two operators, okay, and which is an address, and asterisk is called as an indirection operator. Now, it is recommended that before using a pointer, they say that it is always better to initialize a pointer. Playing with uninitialized pointer basically is inviting in trouble. So how to initialize? So we have gone through these two attempts, and initialization of a pointer after its declaration. So this is an only declaration which is happening, and then comes an initialization. The pointer p1 is initialized with an address of obviously, okay, the address of a. Whereas in this case, the two things, declaration and initialization, they are clubbed together and they're happening, okay, simultaneously. And then this is very important statement one should make a note of, that if p is a pointer, then after its declaration, as and when we are writing down in our program asterisk p, it means that, okay, we are talking about the value of a variable whose address right now is given to a pointer, or indirectly speaking, we are talking about such a variable itself. And we have gone through some simple examples for me to really make a sense out of this. So we have two variables declared and two pointers declared. P1 and P2 are declared as pointer to integer type. So they are meant for holding an address of any integer type of a variable. And if we take a snapshot, this is only a diagrammatic representation, okay, for we to better understand. So with the assumption that the address of X happens to be, okay, 1000, we are making this assumption for a clear understanding and better visualization. And if we assume that the address of Y happens to be 1004, so it means that diagrammatically we will say that somewhere in a memory at a location 1000, X is sitting, and somewhere in a memory at a location, basically, okay, I'll just write down it to the side. So 1004, Y ka value is recorded. So P1 is pointing to X and P2 is pointing to Y right now, because the addresses of X and Y, they are handed over to P1 and P2 respectively. So if we write down this kind of a statement, so this is indirectly P1, as P1 is pointing to X, so it is as good as we are saying this is X, and as P2 is pointing to Y, so this is as good as Y. So the indirect meaning of this is we are saying X ka value should be changed, and should be changed by adding 100 to the Y ka value. So the Y ka value now becomes, okay, X ka value, sorry, becomes 120, and Y ka value still remains 20. Now if we write it like this, so this is Y is equal to, okay, X minus 40. X has been changed to 120, so it becomes Y ka value is now, okay, 80, and then we are displaying. So you just look at X ka value is now 120 and Y ka value is 80. Asterisk P1 ka bhi matlab X hi hota hai, so it is 120, and asterisk P2 indirectly speaking it is Y only, so obviously it is 80. And if we also can display the addresses, so if we are wondering which address right now is with P1 and P2, so we can say that, okay, P1 is equal to ampersand U unsigned. So P1 is holding an address of X, which is 1000 as far as our assumption goes. P2 is holding address of Y, which is 1004 as per our assumption, and address of X is 1000 and address of Y is 1004. Now this is a kind of a redirection. So now the address which is there with P2 is handed over to P1. So P1 also will start holding the same address which is there with P2. And the net effect of this is now P1 also receives 1004 as an address, and P1 also start pointing to, obviously, okay, Y, because 1004 happens to be an address of Y. So now due to this statement, the net effect is both P1 and P2, they are pointing to Y only. And that is the reason now if we talk about asterisk P1 or asterisk P2, this indirectly means Y only, and that is the reason you'll find that asterisk P1 ka bhi value and asterisk P2 ka value is displayed as 80. Now, my dear friends, one of the important utility among many, really speaking, as far as a pointer is concerned, because when it comes to calling a function, we know that, okay, there are two ways of calling a function: call by value and call by reference. And if you look at this, what is appearing there, so now what happens is that this is an attempt right now. Just please, okay, look at this part at the bottom side of this slide. So this is an attempt to declare one variable whose name is A, we have declared, and the value set to 10. This is an attempt basically, okay, to declare another variable B, and the value of B is also set to the value of A, which is 10. And now if we write down B is equal to B plus 60, it is common sense here. Okay, now this will result into 10 plus 60, and the value of B becomes 60, but the value of A still remains 10 only. However, now if we change this scenario, if now B is declared as a pointer, so what is happening? We have declared a variable A which is set to 10, and now because of this statement, we are having a pointer, and the pointer receives the address of A, so the pointer starts pointing to A, and that is the reason if we write down asterisk B is equal to asterisk B plus 60, so actually this means that we are playing with the value of A, rather we are playing, okay, with the contents of the memory location where the value of A is recorded. So this changes the value of basically, okay, A to 70. So this is something what you should notice, and this is basically an essence of call by value and call by reference. So in call by value, when we call a function, the value is passed, yeah, is communicated to the function. So in this case, main function is having a local variable A which is set to 10. Then we are calling a function f, and the value of A is communicated. So the net effect of this is, effect wise, if you look at it, is as good as the function ka parameter, which is x, is receiving a ka value, which is 10 in this case. So x is equal to x plus 60 only will change a value of x to 70, but will not affect the value of it. Is similar to this what I'm talking about. You can correlate it with this example. So the value of x changes inside a function, and x being a local variable, moment the execution of the function gets over, that is end of the story. Local variable obviously, okay, no longer will be there in the existence, because we know that the local variable ka storage class is nothing but automatic. So automatic variable comes into the existence when the execution of the function begins, and the automatic variable, okay, just goes off when the execution of the function gets over. So this is a net effect, and that is the reason finally, okay, when the main function proceeds with the remaining part, it displays a ka value, and the output will find that, okay, appears to be 10. So the what I'm trying to tell you, in call by value, the change applied, okay, listen carefully, the change applied to the parameter inside a function is not getting reflected on the corresponding actual parameter. So this a, actually when we call a function, a is an actual parameter and x is a formal parameter. Let me write down that. I know that, okay, everyone knows this, but then, okay, x basically is regarded as formal parameter. And yeah, when we are calling a function, so the value what we specify there, the parameter what we specify in function call is called as an actual parameter. So what our observation says, the changes applied to formal parameter, they are not happening, okay, simultaneously on the actual parameter. This is call by value. So the changes done by function is not made available to the calling function. So sometimes we need it, okay, we need to say that you take this function, I'm calling you, you please, okay, take this, I'm handing over this to you, and you apply the changes, and the changes should be visible to me and should be made available to me. So that is what it happens in pass by address or call by address or call by reference. So now in call by reference, you need to have a formal parameter declared as a pointer. So if you just look at x, and if we ask x, okay, now what is your purpose? So x will say, I'm being a pointer. My purpose is to hold an address. What I should get assigned with is an address. So when we call a function, okay, when we are using call by address, so we need to send an address. Okay, just please look at this. It is and a. We are required to send an address. And what is the net effect? The net effect is something like this. So x will start pointing to, so wherever a is there, whichever memory location the value of a is recorded initially, which is set to 10, the pointer x will start pointing to it. And now when we write down asterisk x is equal to asterisk x plus 60, so we are saying that the value of a variable whose address is with x should be added with 60, and then it should be assigned to the same variable. So this will change to 70. So this is how, when the function is playing with the formal parameter, actually it is performing an operation on the actual parameter, and that's the reason you will find that, okay, the value of a will get set to 70. So this is what we normally, okay, talk about. And then you people know, my dear friends, okay, the most standard example which normally is we quote in this case is a swap. We write a function to swap the values of two variables, and then, okay, that is how it's done. So I will not take you through that swap function, but then one more basically, okay, so a function indirectly returning multiple values to call a function, that again also happens to be an utility. We know that the function can, okay, only return at most one value, but by using call by reference indirectly, the changes happening in the function can be made available to the function. So indirectly it is returning as good as, okay, multiple value. So now if I ask you, okay, look at the function and tell me what is the name of the function. So you will say that, sir, the name of the function happens to be fun. Yes, it is fun. So what is the return type? The return type of this function is void. It means that directly the function is not going to send back and return back any value. How many parameters? So obviously, okay, the answer expected is 3 parameters. So you'll say 3 parameters. And then can we say that, okay, among these 3 parameters, first parameter is value parameter, means it is employing call by value, and second parameter is second and really third and I'll just write it, third and second parameter are reference parameters. It means that because pointers are used, so you just look, B is a pointer and C is a pointer. So B will employ call by reference mechanism, C will support call by reference mechanism, A will support call by value mechanism. Now if X is set to 10, Y is set to 20, and Z is set to 11, and when we are calling this fun function, it means that you need to only understand one thing: A being a value parameter, whatever changes they are done on A in this function will not be happening on corresponding actual parameter. So even if this function fun is called by passing X at the first place, so the value of X will not be changing, but the value of the second parameter Y and Z will be changing. So originally they were 20 and 111, and then 20 plus 200, the value of Y becomes 220, and the value of Z obviously becomes what? 116, and that is the reason when the function does the job and the main function proceeds with its execution and attempts to display the value, so it will display extra value which is 10, which is unchanged. Obviously it will remain unchanged, but the value of Y has been changed to 220 and the value of Z has been changed to 116. Now if we call again the same function, but now the only change is that we are sending Z in place of the first parameter, and X and Y addresses are sent in place of second and third parameter. So the changes done on A will not be happening on Z. So the Z ka value will remain 116 will not change. But now the value of X and Y will change. X still is 10. So 10 plus 200 becomes 210. So value of X changes to 210, and Y has been already changed to 220. So 220 plus 5 becomes 225. So that is how, what I'm trying to tell you is that this is how the multiple values also they are made available and given back, and the modified values are made available to the calling function. So that is again one of the utility of obviously pointer. Pointer arithmetic is slightly different from the normal arithmetic, my dear friends. And how it is different? Normal, I mean non-pointer arithmetic. And how it is different? It is different in this sense: if P is a pointer and N is an integer type, then P plus minus N is evaluated as P plus minus N multiplied by size of type of P. And for B to better understand, coming in form of an illustration. So let us assume that we have a pointer P declared, and A is a non-pointer variable, so it is holding a value 12.5. So diagrammatically speaking, P is made to assume the address of A, whatever it may be, but then it is pointing to the memory location where the value of A has been recorded. So it is 12.5, and if we assume so if we write down P is equal to P plus 1, so the net effect, really speaking, is not increasing the address by 1, but the increasing the address by 1 multiplied by 4, because the size of the type of P is, because P being basically float type, so the size of that data type is 4. Float ka size hota hai 4, so the net effect is changed by 4. And if we deal with the character, it will be 1, because the size of char happens to be 1. And if you look at this size of float happens to be 4. And we need to understand this because this will be very helpful, and especially when we are trying to just understand the relationship in between array and pointer. And we already had a discussion on array. Array is nothing but is a collection of singular type of elements and variables, and the elements of an array are always stored in consecutive memory locations, in a consecutive manner, one after another. So if we declare array A and the size is set to 4, and let us assume that we have specified only I need to write down one more value here. 1.1 followed by, please, okay, ignore this. There is one more value which is set, which is 6.7. So if we assume that the address, the base address, the starting address of this array is 1050, and array is float type, so every element of an array will consume 4 bytes ka chunk. So 1050 से लेकर 1053 तक basically, okay, is a memory space allocated to A of 0. Then comes the next 4 bytes ka chunk being represented by A of 1, and so on and so forth. And the values are set to 2.3, 4.5, 1.1, and 6.7. Now the base address or a starting address of an array is 1050 as far as our assumption is concerned. Okay, we already have made this assumption. Now the meaning of this is the name of an array is always its starting address. So if you just look at it, name of an array is always its starting address. So if you just write down A, it means that it is a starting address. And what is the address of the very first element of an array, that is A of 0? It is also 1050. But obviously, pehle element ka address is always the starting address, the base address. And now if you just look at what is A of 0, A of 0 ka matlab hai value. And then that is the reason if I write down asterisk A plus 0. So now if I ask you what is A plus 0, A plus 0, A is 1050. So this is 1050, sorry, 10 and 50 plus 0 is 1050. And the value sitting at 1050 address is the value of A of 0, which is 2.3. Now if I write down what is A of 1, so if you just look at this A of 1, okay, please look at this. Now A plus 1 is nothing but 1050 plus 1, but the word of caution is 1050 is address. Address ka matlab hai pointer. Address arithmetic is different from a normal arithmetic. And how it goes? So this is actually 1050 plus 1 multiplied by 4, because the size of float is 4, and that is the reason what we get is 1054. And what is a value sitting at this address 1054? It is a value of A of 1, which is 4.5. That is the reason, okay, this becomes 1050, and A of 1 is also 10. So the moral of the story is asterisk A plus I is A plus I, and this is a correlation what we can identify. So A of I is same as asterisk A plus I, and A of I is same as A plus I. To make a pointer to point to an 1D array, we can write down, okay, the pointer name is equal to array name. So this is a very simple statement to make a pointer to start pointing to basically, okay, the base of and very first element of the array. So this is a simple correlation, and if I want to okay, just highlight this, this is what I'm telling you. So this is a correlation, and A of I can be replaced by just writing down A plus I or I plus A. A of I can be replaced by just writing down asterisk A plus I or I square bracket may, and this is, okay, very interesting. Okay, so A of I also can be, for A of I can also be expressed as I of A in C language. Okay, so to understand this in a better manner, if we have a array which is initialized with 10, 20, 30, 40, 50, and if we have a pointer asterisk P, if we want this pointer to start pointing to the beginning of this array, so I'll be writing down just P is equal to A, or I'll be writing down, okay, P is equal to and A of 0, one and the same thing. Now similarly, I can do it for a two-dimensional array also. So there is a very set correlation in between two-dimensional array. So it goes something like this. A of ij can be also expressed as asterisk parenthesis asterisk A plus I parenthesis close plus j, and address of a element of two-dimensional array at the location ij is same as asterisk A plus I bracket close plus j. So this is basically, okay, for a 2D array, two-dimensional array. So this is how you can, okay, play with the contents of 1D array and 2D array. And then what is a benefit of using an array for processing the elements of an array? So it is regarded as an attempt to okay, optimize it results into a bit of optimization, because even if we are in a program, if we write down something like a of I, which is a standard notation, an array notation, so internally the compiler always will replace this with asterisk a plus I. So now if you use this asterisk a plus I, so obviously, okay, the time required to do this conversion can be saved upon in a, obviously, runtime. So, and that results into what we can say, a kind of an optimization. Now, not only pointer, and there is an endless sequence and pointer to pointer and so on and so forth. So you can have a pointer to pointer. So pointer to pointer basically, okay, is regarded as an attempt to have a pointer which is meant for pointing to another variable. So a is a non-pointer variable, p is a pointer variable, and p has started pointing to a. Now if you look at, if we assume that, okay, these are the addresses, address of a, this is regarded as address of p, and this is regarded as address of, let us assume that q, because every variable declared will always consume some memory, some chunk in a memory. So even if you declare a pointer, pointer के लिए भी एक separate memory location रखा जाता है for holding the address. And one more thing, irrespective of the type of pointer, size of any pointer, okay, pointer is always same, irrespective of the data type to which it points to. So it is independent, because okay, the pointer is meant for holding an address. So address का size fix होता है. So for 16-bit representation, 32-bit addresses, 64, whatever. But then they are fixed. That is the reason the size of pointer always will be same, irrespective of the data type to which it is pointing. So if someone asks us, okay, we have a variable declaration float and asterisk p, and if we have another variable declaration, say character and asterisk p1, and if someone asks us, what is the size of, okay, this pointer, and what is the size of p1, so we'll say that the size of both p and p1 is 2 bytes or 4 bytes depending upon a platform, but it will be same. That is what I'm telling you. It will be definitely same and will not be different. So now what is happening in this case, p is handed over with the address of a. So p starts holding an address of a which is 1000 and will start pointing to, obviously, okay, a. And then we are declaring a pointer to pointer. 2 asterisk means pointer to pointer. So this q also will start holding an address of p. So q is holding an address of p which is 1004 as far as our assumption is concerned. And then if we write down just p, we'll get 1000. If we write down asterisk p, so it is the value of a memory to which the pointer is pointing, which is 12. So 12. If we simply write down q, so q is holding an address of p, so which is 1004. If we write down asterisk q, so obviously, okay, an asterisk cube is the value basically which is recorded there at this location 1004, which is you cannot call it as a value, but whatever is there at a location 1004, it will talk about that, which is 1000. And if I write down asterisk asterisk cube, so it means that the value of a variable to which is pointed by a pointer whose address is recorded at this location 1002. So this is a concept of an pointer to pointer. And the big question is how to pass an array to a function. So to pass array as a parameter to the function, the actual parameter should be its starting address. That's all. So if I'm planning to have a function sort, I will not take you through the sorting mechanism, my dear friends, but then, okay, what I'm trying to convince you is that when I'm calling a sort function, look at this, when I'm calling a sort function, so I need to simply, because we know that, okay, the name of array is always its starting address. So If we want to pass the entire array, I'll be simply writing down the name of array, which is X here. So it is an attempt regarded as an attempt to pass an entire array. But the fact remains, it is not actually we are passing an array. We are passing the starting address of an array, so that okay, this pointer and array, actually array name is a pointer to itself. So this pointer will start pointing to X, and whatever changes are happening on A here will get reflected on X. So that is how we can pass pointer or rather an array to, and inherently it supports an call by reference mechanism. So when okay, the sort function starts playing with the contents of this array with a name A, actually the contents of an array X is getting sorted. Okay, so that is what I'm telling you. This is how we can pass 1D array. And when it comes to a 2D array, the same story repeats. If you have a 2D array, if you plan to pass a 2D array to the function, your actual parameter must be simply the name of an array, simply the name of an array. That's all. So X, Y, and Z, something like that. And your formal parameter must be declared as a proper 2D array. And your the row size did not be specified. It is not mandatory, so it did not be specified. So that is how basically okay it goes. This is how the relationship goes in between. And in fact, if someone asks us, you please write down this by using a pointer notation, so we can write down this by using a pointer notation. Now from user perspective, it appears to be tedious, so the choice always is left to you, but then we can write down. Okay, so Cij can be expressed as asterisk C plus I plus j is equal to Aij can be expressed as asterisk A plus I plus j, and then which may plus Ri, this plus, and Bij can be expressed as asterisk and B plus I plus j. That is what I'm telling you. This is how the relationship goes. And if you ask me about an 1D array, so the 1D array ka bhi story remains same. So whenever I am writing down A of I always have an option available of expressing that as asterisk A plus I. And as A of j can be expressed as asterisk A plus j also. So this option is always there, and then okay, it is left to an individual unless it is explicitly specified. So it is left to an individual. And user ke liye, obviously from user perspective, sticking to a normal array notation appears to be more what we can say closer to the way we think. So I'll be sending you this link also because we believe that okay is जिंदगी एक इम्तिहान होती है. So it's basically you need to keep proving yourself okay in a journey what we call it as a life. So I wish you all the best, but then our story is not getting over here. I want I'll be taking you to another beauty basically which is supported by a pointer and which is called as a dynamic memory allocation. So let me take you through that discussion also. So dynamic memory allocation, and then okay we say that the life involves a lot of dynamics and the kind of dynamism. Okay, what nothing is static, as they say. Okay, everything keeps on changing. So it's always better we love this dynamics of the life. And there is one more quote which goes, you get as much you deserve, no less, no more. And this is basically okay in theme of what we call it as a dynamic memory allocation. And dynamic memory allocation ka the whole objective and the goal is to ensure that the memory is getting utilized in an optimal manner. And we are talking about the an attempt to avoid the memory wastage. So that is what I'm telling you. As much it is required, only that much memory should be allocated, no less, no more. So this is dynamic allocation. It means that the memory is allocated, deallocated during the runtime, and not it is a static allocation which happens during the compile time. So which are those functions basically? Okay, so the functions happens to be, and then you need to include a header file alloc.h as and when you are planning to make use of these functions. So these are a few functions for an allocation. So we have a function called as a malloc, memory allocation. So it goes something like this. Okay, the malloc function, you need to specify what chunk and how many bytes of memory you actually want for the purpose. So how much of memory is required to be allocated is a request. Malloc is a request, and then we need to apply typecasting. So the typecasting is very important. The reason is that the return type of an actual, if you look at the definition or the prototype of an malloc, so malloc basically, okay, returns a void pointer. So the malloc function returns a void pointer, and void pointer is a generic pointer. And the beauty of this generic pointer is that the pointer can be used for holding an address of any other what we can say pointer or any type of an variable. So now if you look at this, let me note one simple thing. Let us do it here. So if I have a pointer declared as of an integer type, and let us assume that we have a variable, a non-pointer variable, obviously, okay, a, which is set to 10. We have another variable asterisk p1, and then a variable b is set to 5.2, something like this. So if you write down asterisk p is equal to and a, this is absolutely a valid attempt, because p is meant for holding an address of integer type, and what we are assigning to p is an integer, the address of an integer variable. Now similarly, in the same spirit, if I write down asterisk p1 is equal to, not asterisk, my dear friends, let me correct myself. So this is just okay. So I'm not doing the declaration and definition parallelly. So if I write down p1 is equal to and b, so this is again an absolutely valid attempt. However, if I write down p is equal to and b, so this will be regarded as an invalid attempt, because b is a float type of a variable, and we have declared p as an integer pointer to an integer type. So you are not allowed to assign a float type of an address to a pointer which is meant for holding the addresses of integer type variables. So that is a problem. But then why we call void pointer as a generic pointer? Because if I declare basically, okay, void, and say let us that I call it as a VP. So now having this also in a declaration, so you enjoy the spirit or a liberty of just writing down a, this is valid, VP is equal to and B, this is absolutely valid. The only thing is that after you do this, as and when you are trying to access the value by using a void point of an pointer, you need to do the typecasting. So if I want the value to be displayed, so I need to, okay, typecast this with I need to say that, okay, it is what we can say, say float and asterisk, okay, something like this. Or rather, I will show it something like this, which is more appropriate. So I'll say that please regard right now VP as a float type of an pointer. So then if we attempt to access the value assigned to this pointer, assuming that it is pointing to B, then what will happen indirectly, it is a message to say that please pick up the contents which are represented by 4 bytes, because, okay, the size of float happens to be in 4 bytes. And why this is required? Because void is actually is not an object. So void का कुछ size नहीं होता है, जैसा float का size 4 होता है, या int size basically is 2 bytes or 4 bytes, character size is 1 byte in C programming language. Void doesn't have any size. So if you don't specify in size, how basically your system will understand the value needs to be decided by using how many consecutive memory locations. So that's the reason the typecasting is required. Now coming back, what I'm telling you is that malloc returns a void type of an pointer. So that is the reason this typecasting is required. So if we want a memory to get allocated, whose size should be uh, yeah, the memory is sufficient enough to accommodate n integers. So n multiplied by size of int we need to write down. So if integer consumes 2 bytes, and if n is equal to 10, so actually to accommodate 10 integers we want a chunk of 20 bytes, or on a platform where integer consumes 2 bytes, and if it is a platform where the integer is consuming 4 bytes, so obviously okay, it should be in 40 bytes. So for our system, or rather our program, to become independent of typically the platform, it is always better we are using this size of operator. If we write down multiplied by 2, so it will work fine on those platforms where integer size happens to be 2, but will not work fine on the platform where the integer consumes 4 bytes. So that's the reason we need to write down this, and this is how we are doing the typecasting. So p being an integer type, so we are saying the pointer written by the malloc function is required to be regarded as an integer type of an pointer. So pointer p starts pointing to such allocated block, and to access element p uses asterisk p plus I or p of I. And initially the allocated memory holds unpredictable. The chunk which gets assigned, which gets allocated, and when this chunk is the pointer p starts pointing to this chunk of memory locations, so all the contents are unpredictable basically, okay, the garbage, so we cannot comment on that. And one more thing is, if, as I said, this is a request. If this request, if let us assume that for some reason this much of a memory, the requested memory cannot be allocated, in that case the malloc function returns null pointer, saying that okay, this is your request cannot be okay, what we can say, handled, or cannot be satisfied because that much memory may not be there, or there is some problem in assigning a memory. So this to convey, to report this unavailability of memory or an unsuccessful attempt to allocate a memory, the function returns a null pointer. And the same thing happens with a calloc also. The only difference in between these two functions which are made available for allocation of the dynamic allocation of a memory, malloc and calloc, is only one thing. In terms of a parameter, the malloc requires only one parameter, whereas calloc requires two parameters. You need to specify kitne elements ke liye, for how many elements you are planning to assign a memory, and what is the size of every element. So what normally we do in form of a multiplication, yahan n multiplied by size of n int, the same thing we need to write down n comma size of int. Internally the calloc function does the multiplication and identifies the size in terms of n bytes. And the second difference is, apart from the number of parameters, okay, the memory chunk allocated by calloc always will be filled by null values and zero values. So C stand for clear everything and then allocate kind of thing. So this is again the second difference. So this is something about dynamic memory allocation. So this is a great utility, okay, especially when you are planning to ensure that only required amount of memory is getting utilized, and then there is no wastage happening, and you attempt to enjoy the benefit of allocation of an memory and then reallocation of an memory, and also an ability to release a memory when you realize that no longer in a program further we need this memory to be available for the purpose. So you can better release the memory by using a free function so that it can be utilized for another purpose. So this is kind of a recycling which can be carried out by using a free. So this is about the two functions which are available for the memory allocation. You have a function for reallocation. Reallocation actually is a costlier affair, but sometimes our estimation may go wrong, and we may realize that, yeah, okay, what we earlier have demanded now is not satisfying and is not sufficient. So probably we are looking for, okay, more of a memory, or we need to cut down. So reallocation is also possible. So to reallocate, we need to use realloc, and then you need to specify the pointer right now, which is pointing to the allocated memory, and you need to specify the new size. So for example, if the pointer P is already pointing to the dynamically allocated memory, and if you want, okay, further 10, what we can say, if you are looking for an additional memory capable enough to accommodate further 10 integers, so you can say that n plus 10 multiplied by size of int. So originally you have allocated a memory for n if n is equal to 4, iska matlab hai, and then if size of int, if we assume that it is 2 bytes, so then it means that total 8 bytes का chunk is assigned to pointer P, and then you realize nahi yaar, और 10 elements को accommodate करना है. So obviously what you say is that uh, it is 10 plus 4, 14, 14 multiplied by 2, 28, and 28 bytes ka chunk can easily accommodate 14 integer type of elements. So pointer P starts pointing to such a newly allocated block, and the beauty of this is that the original content will not get lost, they will still remain there, okay. So even if the reallocation is happening, even if the new chunk somewhere else of a memory is getting allocated, the original contents will remain intact and will be retained and will be made available for the subsequent processing. And then, my dear friends, because we believe, as I said, recycling is mother nature's very characteristic. Ma Vasundhara, okay, is everything what we throw, and you, okay, Ma Vasundhara tries to do the recycling. So this recycling is very important, otherwise it will start troubling us, and we are a party and we are experiencing this, okay, the junk which is troubling basically, okay, the environment. So for the same philosophy, my dear friends, okay, we have a free function made available. So as and when we realize now no longer the memory is required, so it can be released so that it can be reutilized. So this is a free function available for the purpose. And a simple example used for an illustration is, again, okay, we are talking about a sorting function, but now we are using a dynamic memory allocation. Earlier, if instead of this, if we declare say array of 100, if we do it something like this, so this is basically a static declaration, and we are saying that my program should be capable enough to accommodate 100 elements of float type, and the total memory which gets allocated becomes 400. And now further what we do is that generally we ask user, now you decide upon the size, how many elements you are right now interested in this execution. And if user enters, okay, a value something like 4 or 5, if n is entered as 5, it means that your user is saying that I want right now, okay, to play with only 5 float type of elements. And what provision we have made, we have a provision to accommodate 100 float type of values. So only 5 are getting utilized, and then remaining 95 locations, basically not 95 really speaking, 95 multiplied by 4, because every float type of a variable consumes 4. So that much of a memory will not be utilized, and underutilization is not good. It is as good as, okay, leading to an wastage. So now what is happening? We are saying, user, you first decide how many elements you want to play with, and then this is an attempt only to allocate that much of a memory, no less, no more. And pointer is a float type, so we are applying typecasting here. So we are saying calloc, you please allocate a memory which you calculate by multiplying n and the size of float, which is 4. So if n is 5, so 5 multiplied by 4, only 20 bytes the chunk will get allocated. And this is recommended. As I said, a calloc is a request. So it is not necessary that every time this attempt to allocate memory dynamically will be a success. So it is recommended that you, before you proceed, you always check whether the attempt has gone successful or not. And how to do that? It's very simple. Okay, you just check what kind of value the pointer has received, what kind of an address. If the pointer is matching with null, iska matlab calloc has returned a null pointer. So it means that the allocation fails. and there is no point in going ahead because okay, there is no memory made available, so we simply return 0. But then if this is not true, then we proceed to accept and sort, and then after everything is done, as I said, okay, it is good practice to release a memory. So we release a memory, and in this case you may not realize, because immediately after we release a memory, we are just okay saying bye bye, and that is the end of the main function also. But this becomes a good practice if you're writing down a big application, and then okay, by some point in a big application midway you realize that okay, at least the job of allocated memory already is done. It has served its purpose. It doesn't needs to be made available okay hereafter. So you can free it, and then that chunk of a memory can be made available for some other purpose. Now taking you ahead, we also have the concept of user-defined data types. So user-defined data type is, it is you to decide the ingredients depending upon the application for which you are writing down a program. So you decide the ingredients, you prepare your own dish. So that is the reason it is called as a user-defined data type. So structure basically is user-defined data type, and it represents collection of variables, elements not necessarily of the same type, and heterogeneous collection. An array happens to be an homogeneous collection. So if let us assume that we are trying to write down a program where we need to play with the details of entity called as a bike, or an object called as a bike. And what details we are talking about? We want company details, the company and the make of the bike and model and the mileage and the cost, something like this. So actually the fact remains, these four things together represents okay one single entity, one single object, and that is a bike. So we don't want this to be kept independent variable declaration. We want this to be treated as a single unit, and we are trying to bind this okay by using user defined data type called as a struct. So we need to write on struct bike and all these ingredients and the elements of the structure or members of the structure. Once we do this, having done this, after we do this template declaration, we can say that this by writing down this, by proposing this in our program, we have created our own data type, and the name of this data type happens to be struct byte. So we have created this data type, and that's the reason it is called as a user defined data type. So now if you want to make use of this in your program, you need to have variables of this type. So we are saying, okay, my data type name is struct byte, and then I'm saying I want these two variables to be declared as of what type? Struct byte type. And eventually, okay, with the new compiler, you don't have to write down struct also. You can simply write down byte b1 comma b2. This is a new thing which is done in C++. So what I want, just wait. Getting a call, and I'll just convey them that I cannot join. Okay. So coming back, these are the two variables, and then we know that okay, once b1 and b2, these two variables are declared, and if we are trying to okay access the values assigned to an individual member, so we need to use a dot operator, okay, and membership operator. So I'll be writing down b1 dot model and b1 dot cost and b1 dot mileage, and so on and so forth. And similarly for printing, it is the same story which is getting repeated. The other way of doing this variable declaration is you write down the template struct bike and everything, and before you put this semicolon, look at this, before you put this semicolon, you can declare the variable there also, b1 comma b2. Instead of declaring it somewhere inside a function, you can declare it here also. But then only the difference is that then this will be regarded as global variables, and this will be regarded as local variables here. And we know that, okay, global variable should be the last weapon what we should draw. As far as possible, we should try to avoid global declaration, because then we are opening an opportunity for these global variables to get changed, altered intentionally and unintentionally, okay, by some another snippet of the program which we don't want to happen without our knowledge. So I always will suggest that this way of variable declaration, you simply declare a template outside, and then variable declaration should be done as and when it is required inside a function or a block. So if we declare b1 and b2, so we have b1 variable equipped with these 4 members. The type of this array is character. So the total size of how much of a memory the first member of this b1 will consume is 20 bytes. Second member again will consume 15 into 1, 15 bytes. And the remaining 2 members are of float type. The size of float is 4. So 1 multiplied by 4, 4 and 4. So the total size becomes obviously, okay, 43 bytes, 20 plus 15 plus 8, 43 bytes. So size of B1 or size of B2 or size of, even if we write down size of struct, sorry, byte also is same, that is 43 bytes. And if you want to have many such variables, so you can also create an array of structure type, just writing down B50 iska matlab, okay, we have created in a single shot array of structure byte type, and every element is capable of representing one element of the structure, okay. So now this array can accommodate the details of 50 bytes. Or you also have an option of doing it in a dynamic allocation manner. You can use Malloc, or you can also use basically calloc function available for the purpose. So I'm writing down Malloc and n multiplied by size of struct byte, and then we need to typecast it saying that the pointer returned by Malloc function should be treated as if it is a pointer to a structure byte. So this is how we can do it for structure. And type definition again is one of the very useful utility, and we can really, okay, it can be regarded, we can do it like this, and this can be regarded as an attempt to give one more name to an existing data type which is float. So in accordance with the given situation, sometimes we may feel that using real instead of float is more appropriate in the context, basically, okay, for which we are writing down the program or the activity at hand, the problem at hand. We want sometimes that we should call it as real. So you can simply write down type def float and real. It means that we are saying float also now in additionally can be represented by one more name, that is an real. So that is a type def. So we can say that type def struct bike and bike. Iska matlab hai कि we have assigned a new name to this struct bike as a bike. So when we try to declare a variable, then once we do the type def, so you don't have to write down, okay, struct and then bike and then bk and 50. You simply need to write down, okay, so just bike, because we have done the type definition. So it's a very useful utility, basically, okay, in many aspects, really speaking. And then we can do it like this. So that is one benefit of, okay, give a new name to type in accordance with the context, okay, as I said. Then we have a concept of a nested structure. So a structure within a structure is a nested structure. So if a member of a structure is another structure type, it is called as a nested structure. So as far as the first definition is concerned, this is an illustration. So you have declared a structure triangle, and we know that okay, the triangle is represented by 3 vertices or 3 points. So we'll say that okay, actually we'll create one more structure inside, and every point is represented, assuming that we are talking about a 2D point. So on a two-dimensional terrain or two-dimensional plane, in a two-dimensional plane. So not a 3D space. So x comma y, every point is represented by an identified x coordinate value and y coordinate, and we want such 3 vertices. So v1 is struct point type, v2 is also struct point type, and v3 is also struct point type. इसका मतलब है v1 is having 2 ingredients x and y, v2 also will have okay 2 ingredients x and y, and v3 will have okay 2 things for made available for its description x and y. And then triangle is defined by the 3 vertices. So this is one way. Second way is to first declare a point type of a structure, alag se. So we have declared a structure called as a point. And now when we are declaring basically, okay, a structure pointer will say, inside a structure pointer, we want 3 variables, v1, v2, v3, to be of what type? Struct point type. So these are the 2 ways, but then the second is more beneficial. So I will go and will recommend that you adopt this way of using a structure inside structure. And now if I declare a variable t1 here, if you just look at t1 is what type? T1 is struct triangle type. And that is the reason to access the members of T1, I'll say T1K first vertex ka x coordinate value. So I need to write down T1 dot V1 dot x. So it is the vertex V1 x coordinate value of a vertex V1 belonging to the triangle represented by T1. So you need to use obviously okay 2 times this dot symbol. This is something about a nested structure, and there is one more concept which is called as what we can say. Just please excuse me. Let's see. So, if the member of a structure is a pointer to the structure itself, so it is called as a self-referencing structure. So if I ask you what are the ingredients of this structure node, you will say that okay, data and next. If I further ask you data is pointer or non-pointer type, so you will say that it is non-pointer type. If I ask you okay, what is your opinion about the next? In fact, it should be small n, case sensitive language, my dear friend. So okay, great for that mistake or typing mistake. So next, so this is small n. So if I ask you, tell me what is your opinion about this next, so you'll say that sir it is pointer. Then if I ask you what is the type of this pointer, so it is struct node. So is it not next is meant for pointing to the variable of the struct node itself? So if the member of a structure is a pointer to itself, it is called as a self-referencing structure. And this is again very, very useful, especially when you are dealing with the linked list, implementation of a stack or a cube or a linked list itself, or in a trees, okay, or in a graphs, and if you're trying to do something like the compression and okay decompression by using what we can say, by using different encoding mechanisms. So definitely, okay, this will be a very useful utility of which comes in form of an self-referencing structure. So we also have the concept of a pointer to function. So okay. Certain more points. So if I declare a kind of an pointer, so let us assume that I say it is So now if someone asks us, okay, how you will interpret this, so I'll say that this is an attempt to declare a pointer to function which returns float type result value and requires two parameters of int type, because okay, we are writing on int and int, so this can be regarded as an pointer to function. We know that okay, the function doesn't have a size, but then every function ka copy will get recorded in a memory और उसका भी एक starting address होता है. The function also will have the code begins with some address and the code gets recorded in a main memory. So this pointer will start pointing to the function, and by using pointer also we can start calling the function. So if we have a function declared something like this float, and let us in that add and int and int, let us just like randomly, and we have done something inside and we want the pointer to start pointing. So what we can do is that we can simply say ptr is equal to add in our program. So we are saying that pointer, as you are a pointer made eligible to point to any function whose return value is float and is required to be equipped with two integer type of an parameter. So I'm assigning the address of the function add to you. So we can just write down ptr and two parameters. So it will result into the execution of the add function. So it not exactly, but then we can make the same pointer to be utilized for calling different functions. So it's slightly indirectly speaking very close to something called as an polymorphism. And similarly, with the same spirit, if someone asks us, okay, something like this, if someone asks us, what is your opinion about, say, asterisk ptr and 10? So I'll say that this is declared as a pointer to an array of size 10. And if someone says, okay, what is your opinion about so I'll say that okay, ptr is declared as array of pointer. So ptr becomes array of pointer in this case, and which can have 10 elements. So every element of this array is capable of, this is array of pointer, I can write down it as array of pointer, and every element is an integer type of an pointer, whereas in this case this is a pointer to an array of 10 integers. So this is pointer to an array. This is difference as far as a declaration is concerned. So actually, as far as the attempt to uncover and take you back and okay, make you to recollect all those old things you have collected, you have come across, you have played with in your journey till this point, maybe in semester 7 or 5, whichever, you already have used this C language for variety of purpose. So it was an attempt to just okay again refresh you with those concepts. So from my side, Hakuna Matata. So no worries, my dear friends. Okay, start working on your skill set, and there are lot many testing platforms made available. One of that is an HackerRank. So you can go, you can create your okay like an login there, register there, and then there are lot many challenges available, and you start taking those challenges and playing with them, and then okay, that will definitely add to your or will help you to improve your programming skill set. So this is something what I was trying to okay just make available to you, and then let us go through some simple examples, typically speaking. Okay, we are supposed to find the output, and let us do this exercise. So what will be the output if I'm talking about, and please regard this as, okay, so this is small I, this case sensitive language, so please regard this as I. So now this is a string. A is a string, character type of an array, and terminated by \0, which is null, is nothing but a string. So A is initialized with what we say, a blank space. There is one single blank space, okay, here. So one blank space, let it be, it doesn't matter. So if printf %s and A, so at least there is one single character. That is what I want you to visualize. So there is one single blank space. Blank space is also a character. So what I want to tell you is that if you just think of this printf is a function which returns number of characters it displays, and the string is equipped with one character even if it is blank. So obviously what will happen, printf will display this blank, which will not be visible to us anyhow, but then it definitely will return 1 because it has displayed one character. And when printf return 1, so that 1 becomes an if condition, and in C language any non-zero value is regarded as true. So if condition becomes true, and what appears on the screen is okay. So the output of this will be one blank followed by an okay. Okay, something like this, and not a program error. So it displays output will be obviously okay. Now if we have hash defined sqra, which is a parameterized macro, इसको macro कहा जाता है, and उसका definition है a into a, and simple substitution होता है, we know that. So when the main function is getting called, or when the compilation, and this is a preprocessor, my dear friend, so preprocessor always plays a role. Preprocessing happens prior to compilation. So before compilation takes place, what happens? The preprocessor will come and will replace this SQR with what we are sending. The macro is specified here, and 4 is the parameter. So it will simply get replaced by 4 into 4. So when the compiler starts compiling this, the statement appears for a compiler. The statement becomes I is equal to 64 divided by 4 multiplied by 4. And that is reason now generally we tend to immediately say कि SQR है, नाम उसका SQR है तो square root आएगा. So we tend to say कि it is 4 into 4 basically, okay, which is obviously 16, and then 64 divided by 16 becomes 4. No, my dear friends. Okay, what happens in this case is actually, just wait. So what is happening? So what is happening is in this case, it is 64 divided by 4 into 4. So first 64 will get divided by 4, and what we get is 16, and then this 16 will get multiplied by 4. So what we get is 64. So output of this will be 64 and not, my dear friend, 4. The output will be 64. Now if you want to be like that, then the other way is you need to also put this asterisk into asterisk in a bracket. Had it been a case if you just replace this with asterisk into asterisk but inside a bracket, then the substitution will be यहाँ 4 into 4 नहीं होगा, bracket में 4 into 4 जाएगा. In that case it will be 64 divided by 16, which becomes 4. So we need to be careful while solving this Appears to be very simple, but then we need to be a bit careful. So if you look at this and this side, ah, so this is a left shift operator, and -1 is getting shifted to the left hand side by 4 bit positions, and the value expected is in hexadecimal format. X stands for hexadecimal format, and -1 16 bit रिप्रेजेंटेशन की अगर बात करेंगे तो -1, बिकॉज हमने पहले ही बात की थी कि negative numbers are recorded, okay, negative values are recorded in a 2's complement manner. So actually in a memory ये जो -1 है एक, so this my 1 कैसा लिखेंगे हम लोग, 0000 and finally 01. This is how the 1 looks like the binary equivalent. If we take 2's complement of this, so what we need to do, as long as while in a journey from right to left, till we are not coming across the first one, we are not supposed to, okay, invert and copy. The first one should be copied as it is, and remaining zeros all will get converted into 1. So actually the -1 ka, how this -1 will look inside a memory is everything as 1. So this is how the -1 will get recorded in a memory. And when we are shifting this in the left hand direction by 4 bit positions, so what will happen, this leftmost 4 bits will fall down, and 4 zeros will appear from the right hand side, zeros, because vacancies will get filled by zeros. So finally, after doing this, how this chunk will look like, it will be something like this after the shifting takes place. So 1 1 1 1, then again 1 1 1 and 1. So this is second nibble, 4 bytes का nibble होता है, 4 bits का, 1 1 1 1, और बाकी अभी जो right hand side से 4 zeros will get inserted, 4 zeros, so 0 0 0 and 0. Now if we are trying to look at this कि hexadecimal में कैसा लगेगा, तो hexadecimal में, to convert a binary into hexadecimal, we know that, okay, the chunk of 4 bits should be converted in the hexadecimal equivalent. So this is F, this 4 bits also will be F, this 4 bits also will be F, and this 4 bits will be 0. So the output of this will be 0x, because, okay, percentage X first prints 0x and then followed by FF, F and 0 will be the output of this program. Now, if you ask me what will be the output of this printf, so when printf is meant for displaying basically, okay, time. So how many characters are there in time? 4. So printf always returns the number of characters it has displayed. So the result of printf will be 4, and this 4 will get displayed. But prior to that, printf will play a role. So output of this will be pehle time aayega, and then, okay, 4 will appear. So will be the output of this program. Now, if you look at this, I is set to 0 and j is 10. And if you look at this, okay, the if condition, I and j plus plus. Now this is ANDing operation, and I is 0. So 0 का मतलब false है, और ANDing operation में if the left hand side is 0, the right hand side never will be evaluated, because we know that ANDing में एक भी अगर 0 निकला, the result anyhow is going to be 0. So that is the reason the right hand side will not be evaluated at all. So the value of j will not get incremented at all, and the result of this will be 0. So if condition becomes 0, so 0 का मतलब false है. So this if will not play a role, rather this if anyhow it is going to play a role. So the value of I basically is 0, and the value of j still is 10. So the output of this will be 0 dot dot 10. What I'm trying to tell you is that the value of j will not get incremented, because in the logical ANDing, if the left hand side is false, the right hand side will not be allocated at all. So sometimes otherwise we may tend to okay say that 0 dot dot 11. डॉट डॉट क्यों? क्योंकि प्रिंटफ में हमने ये 2 बार डॉट डॉट डाला, इसलिए ये डॉट डॉट, अगर नहीं डालते तो गैप आ जाता है. Similarly, we have a recursive function. So what will be the value of f of 5? So first time when the function is getting called, we are calling it by sending 5, and the word of caution is r is declared as what we say, it is a static variable, and static variable का single copy होता है, and it comes into the existence and will remain there forever till the end of the execution. So the value of r initially will be 0. Now execution of the function begins. The value of n is 5. Yeah, n is 5 obviously, so less than equal to 0 is not true. So it gets into this if condition. Now value of 5 greater than 3 is true. So the value of r is set to 5. The value of r becomes 5, and the function is calling itself by saying f5 minus 2, which is f3 plus 2. So this will be an attempt to the function is trying to return. Now this will result into what? Function f3 is getting called. अभी जब function f3 का मतलब है n का value is 3. When n का value is 3, this if condition becomes false. When it is becoming false, so 3 greater than 3 also will be false. So it will try to return this. And what is it? So it is 3 minus 1, which is 2, and r ka value, which is 5. So it is trying to return f2 plus r. Now what is f2? Again, the function is getting executed, and the value of n is not less than, n ka value abhi 2 hai, so it's not less than equal to 0. So it gets here. This if condition is also false. So it will try to return f1 plus r. So it is resulting into f1 plus r. And again, in a similar fashion, it will result into f0 plus r. But when the function finally is called for by passing 0 as a parameter, when the value of n becomes 0, it terminates the recursion and it simply returns 1. So that is where the recursive functioning call will halt and will start giving back the result. So it will start sending the result back to the previous copy of the same function. So this becomes 1 plus r, which is 5. Value of basically r is 5. So it returns 6. So 6 plus 5. F1 का result 6 आया. So 6 plus 5 becomes 11. So F2 का result 11 आया. So 11 plus 6 becomes 16. So 16 plus 2 becomes 18, and the result of this will be 18. So that is how it goes. So taking you ahead, again, this is a macro as defined. एक macro declare किया गया यहाँ. So we are talking about a macro whose name is print, capital में, and the macro is a parameterized macro I and limit. These are the two parameters, and it is defined as do if I plus plus less than limit and printf gigs please and continue and so on and so forth. But we know that pre-processing always happens prior to the compilation. So whenever there is a preprocessor identifies a macro call, it simply does the replacement. It is just a substitution. So this entire thing will get replaced by before a compilation. So it gets replaced by or substituted by do, and then the value of I is 0. So it becomes if, and I will get replaced by 0, 0 plus plus, and less than limit, and limit will get replaced by 3. Sorry. And don't look at the rest of the thing. I will not talk about that. And what I'm trying to tell you is that when compiler gets this, and when compiler comes across this stuff, the compiler will raise an objection here, and the compiler will say that this is compilation error. So this is because you cannot use an pre and post along with the constant. A plus plus is acceptable, valid है. For 3 plus plus it doesn't make any sense, and that is what it is happening. It is 0 plus plus. So output of this actually will be a compilation error. So these are a few examples. They keep asking basically, okay, in the aptitude programming tests, and they may ask you these things in the interview. So I appeal you all to go through all these basic details, my dear friends. I know that when we are doing this live streaming, most of you prefer to go through these videos, okay, as per your convenience and with your pace. We are aware of that, but then finally what I request you and what I appeal you is, you please go through and then you let us know about all your concerns. We are there to together we can further improve upon and see to it that everyone's chances are getting brighter and brighter for maybe it's getting through the placement, or maybe basically okay aspiring for higher studies. So all these basic fundamentals plays a very vital and important role. I wish you all the best. Thank you very much for being there virtually speaking. And I am assuming that you are going to trouble me a lot by throwing lot of queries and lot of questions. Thank you very much. This is Professor Sachin Deshpande signing off. Thank you very much.
Thank you, Deshpande sir. Should we end the session now?
Yeah, I prefer we will close down. Thank you.
Okay, sir. Thank you, sir. Thank you for conducting the session.